Hey, today we're going to talk about the distance formula. Basically, what the distance formula is when you're in a coordinate plane, you're finding the distance between 2 points. Okay, so this would be your formula, this guy right here, d equals square root of x squared minus, or x2 minus x1 squared plus y2 minus y1 squared. Okay, so we're going to practice how you're going to find distance in a coordinate plane. And first thing we need to do is example number 5. Okay, it says find FG and JK and determine whether FG is congruent to JK. Okay, so the first thing we need to do is plug in our points. Alright, we're going to go ahead and start with segment FG. The first thing you need to do is figure out what ordered pair each of the points are. So for example, F, you're going to go over 1 and up 2. So your ordered pair would be 1, 2. Okay, for your G, you're going to go over 5 and up 5. So that's what its ordered pair would be. Okay, then you have to go ahead and sign the values. We're going to start with this guy. He's going to be x1 and y1. You can start with whatever one you want, it doesn't matter. And this one's going to be x2 and y2. Okay, x2 and y2. Then you simply just have to plug your coordinates in to your distance formula. Okay, so let's go ahead and start. So we got the square root of x2 minus x1, so you have 5 minus 1. And you're going to square that. And then you have to add in y2 minus y1. And y2 minus y1 would be 5 minus 2. And all of that squared. Okay, then you go ahead and simplify. You have 5 minus 1, that gives you 4 squared. And 4 squared is 16. So you have square root of 16 plus 5 minus 2 squared. 5 minus 2 is 3. And 3 squared gives you 9. So that gives you square root of 25. And the square root of 25 gives you 5. Okay, so we know that the segment FG is 5. Okay, so let's go ahead and take a look at JK. We're going to do the same thing. So if you look at J, you have the ordered pair -4, 0. And your K would be -1, -3. We're simply going to plug that into our formula, knowing that this is x1, y1, and x2, y2. I'm going to simply plug that in. Okay, so we have, let's go ahead and zoom in here a little bit. Okay, so we have square root of x2 minus x1. So you have -1 minus -4 squared plus, and then y2 minus y1, which would be -3 minus 0 squared. Okay, so if you go ahead and take care of that, -1 minus -4 is 3. And if you have 3 squared, that gives you 9. And then -3 minus 0 would be -3. And -3 squared gives you 9. And that gives you square root of 18, and then if you plug that in your calculator, you get approximately 4.24. Okay, so while JK and FG look to be congruent, they're slightly different. You'll see that one was 5, one was 4.24, so you were close, but not quite. Okay, go ahead and listen to the next part. Alright, next we're going to talk about the Pythagorean theorem. Basically what the Pythagorean theorem is, says right here, In a right triangle, the sum of the squares of the lengths of the legs is equal to the square of the length of the hypotenuse. Okay, basically all what that wordiness is saying is that the length of side A squared plus the length of side B squared is going to equal C squared. Okay, so this is going to help us find the lengths of some different lengths in triangles. Okay, so let's take a look at a couple of examples right here, and we're going to use the Pythagorean theorem to help us find some different segment lengths. Alright, so let's go ahead and plot our different points. We have the point D, that's 3, 4. Let's go ahead and zoom in here. 3, 4, so we go over 3 and up 4, and that gives us our point. And we have -2, -5, which will be right there. Okay, so what we need to do is go ahead and find our distance formula, and you also use the Pythagorean theorem to help us find different lengths. Okay, so we want to find this length right there. Okay, so remember our distance formula is x2 minus x1 squared plus y2 minus y1 squared. So we're going to plug them in. We have x2 minus x1, so we have -3 or -2 minus 3 squared. Remember, this is x2, x1, y1, y2. Okay, then we have to add in y2 minus y1. That would be -5 minus 4 squared. Okay, then if you go ahead and reduce, you have -2 minus 3, which is -5. So you have -5 squared plus -5 minus 4, and that gives you -9 squared. Then if you reduce even more, -5 times -5 gives you 25. So we have square root of 25 plus, and then -9 times -9 gives us 81. Add those together, that gives you square root of 106. And if you take the square root of 106 on your calculator, that should give you approximately 10.3. Okay, so what that means is that this segment over here in red is approximately 10.3 units. Okay, so that's one way to find the distance, but we also can find the distance using the Pythagorean theorem on this one. Okay, remember our Pythagorean theorem is a squared plus b squared equals c squared. And what we're going to have to do is set up a triangle, or a right triangle. Okay, so we're going to set up a triangle here. That was a really bad line. Let me erase that. Let's use a different color. Okay, that's a little better. Okay, so you see that we've set up a triangle, and now we can set up different side lengths. Okay, so we've got side A, we've got side B, and we've got side C. Alright, side B, we know that if you count over from right here and go over to the corner, you've got 5. So this length of B is 5. And then if you go to side A, you can count up 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 in side A. Okay, but we can't exactly know side C. It goes through the middle of some of those different lattice points, so that we don't really know what it is. So we're going to use our Pythagorean theorem to figure that out. Okay, so over here we're going to plug in our different values. A was 5, so we have 5 squared. Oops, A was 9, excuse me. 9 squared. And then B squared was 5. Okay, we don't know C squared, so that just stays the way it is for now. Okay, then you go ahead and simplify. 9 squared is 81. 5 squared is 25 equals C squared. You add those up, that gives you 106 equals c squared, and then you take the square root, and that gives you approximately 10.3. Okay, so you can see that both of those end up equaling 10.3. You just use a different process. Okay, so on your test, they're going to ask you for both of these different ways, and you're going to have to know how to use both. Okay, example number 7. I would like you to work that on your own. It's the same thing as example 6 up here, so go ahead and use those notes to help you figure out number 7. Have a good one, guys. See ya.